Good morning, pre-algebra students. Today we're going to start a new lesson, chapter 10, lesson 5. So let's find out where that's located. Go up into your classwork, scroll down here to chapter 10, click on that, and it will bring us down here to chapter 10, lesson 5, the completed notes. Click on that and follow along with our lesson today. I'll pull up my notes. So as we look here, we are on lesson 10-5, using sampling to predict. So now we're going to be looking with statistics, okay, how do we sample groups when we're taking a survey? So let's look up here. Let's see, okay, what's the best way to identify what type of sampling technique do we use when surveying a group? So let's follow along right here. So it says, suppose a student conducted a survey about new clubs. They cannot survey every student, so a randomly selected smaller group called a sample is chosen from a larger group or the population. So let's think about what we're saying here. If we were surveying all of Eden Hall, that would be our population. Okay, this is our population here. It's the larger group. Now, we cannot survey all 1,200 kids, so we're going to be picking some of these kids to sample and get their opinion on a new club, let's say. So that group that we are choosing here is known as our sample. That's the smaller group because we cannot survey everybody at Eden Hall. Okay. Then it says the best sample is an unbiased one. We'll talk about biased and unbiased here. Okay. Or one that it's representative of the larger population. So it's a good pick. It's a good, we're trying to pick the ones that do make up that population. Selected at random, which means without a preference, and large enough to provide accurate data. So we don't want to just pick two kids because two kids is not a large enough a sample size in order to come up with some of our views on what the school is looking at or what they believe in or things like that. Okay. So we want to get a larger group. So let's now take a look here at the different types of samples that we are having here. Okay, we have our unbiased our samples here. So the first one is a simple random sample. Okay, what does this mean? That means each item or person in the population is as likely to be chosen as the other. Okay, an example would be 30 student ideas are randomly selected by a computer. An easier way to look at this is, hey, let's take everybody's name, let's drop them into a hat, and let's pick out 5 of them, let's say. So right there, everybody has an equal chance because everybody's name is in the hat, and we could randomly pull out the names from the hat. So that would be considered a simple random sample. Let's look at this next one. Stratified random sample here. So the population is divided into similar non-overlapping groups. A simple random sample is then selected from each group. Okay. A population of election districts can be separated into urban, suburban, and rural strata. An easier way to think about it like this is if we were to sample all of Eden Hall, okay, think about how we could break Eden Hall down into simple groups. We could break it into the 4th grade and do a sample from there. We can break it into the 5th grade, do a sample from there, break it into the 6th grade, do a sample from there, and then review that information. Or if we wanted to, we can say, hey, what we're going to do it is according to the biomes. We would separate everything into the desert, the forest, the grasslands, and the aquatics. Okay, that would be a stratified random sample because we're breaking the population up into groups. Now let's look at the systematic. This deals with a system. So think of the word system when we're dealing with a systematic random sample. Let's take a look and see what they mean here. It says the items or people selected according to specific time or item intervals. So it says here as our example, every 20 minutes, a customer is chosen. So that's dealing with our time. So, okay, we watch our clocks. Hey, every 20 minutes, we're going to stop somebody and ask them a question. Or every 10th customer in line is chosen. We may say, okay, we'll do every 20th, every 30th, every 40th type a person, depending on the size of our population. And that's the person we will get our information from. So these here are the unbiased types of samples. These ones, hey, hey, it's random. Everybody has an equal chance. Unlike we're dealing with our biased, okay? It says here, a sample that is not representative of the population is called a biased sample, okay? A biased sample usually favors a certain part of the population over others, okay? Let's talk about a convenience one, okay? If we look at the convenience sample here, it says it includes members of the population that are easily accessed. That means you're lazy. You just want to do, hey, the first 10 students in line, I'll just pick them and be done with it, okay? That is a biased type of a sample. And also we have voluntary response sample. This is also a biased sample. It involves only people who want to or can participate in the sampling. Okay. The principal sent out an email to the graduating seniors asking them to hold commencement. Seniors are asked to vote through an online poll. So basically, only the ones who want to volunteer and do it will do it, because those are the ones who have the strongest opinions on things. So that right there is a biased type of a sample. So let's take a look at some of the examples that we have here. So our first example states here, to determine the type of music a concert hall's customer likes best, all the people attending a country music concert are surveyed. Identify the sample as biased or unbiased and describe the type. Explain your reasoning. Okay, this is definitely biased. Think about this. What type of concert is this? This is a country music concert. Since it's a country music concert, what type of music do you think these people are going to like? Country music. Very good. So a lot of them are going to be picking, hey, we want more country music in this concert hall. So that's why it is biased. It's out of convenience. You're saying, hey, I'm lazy. I need to get this done. It's out of convenience because you're going to a location where everybody likes the same thing. Think about it like this. If we were to go to a Steeler game and say, hey, who's your favorite team? Guess what the choice is probably going to be? The Steelers, because it's not a random sample. It's more out of convenience. It will be biased because a lot of people are there because they support the Steelers. So let's come back here to this one here. It says, since the survey was taken at a country music concert, people would probably prefer country music. Yes, we know that. All the people were surveyed in one location also. So that's why it's out of convenience. Let's look at the next one here. It says, a hardware store wants feedbacks on its product and on its products and service. The store includes a telephone number on each receipt so customers can call and participate in a survey. Identify the sample as biased or unbiased and describe its type. Explain your reasoning. Well, it's biased and it's voluntary once again, okay? Because remember we said over here, okay? It's biased because it involves only those who want to or can participate in this sample, okay? So it's a biased voluntary sample response. The sample includes only those customers who choose to participate. That's why it's voluntary. Okay, validating and predicting samples. Let's take a look at these ones. Okay, it says, depending on the sample method used, you can make predictions about larger populations. When you make a prediction about a population from a sample of data, you are drawing an inference, okay, which means you're making a guesstimate, okay, about the population. So let's take a look here. Let's see what we have here. So it says, A pet store mailed a survey to residents to determine their favorite pet. 50 people responded, and the results are shown in the table. Is the sample method valid? If so, how many people can you expect to choose dogs or as their favorite pet in the city with 1,585 people? Explain. Okay, so once again, this is voluntary. Only the people who want to respond will respond, and if it's a voluntary type of a sample, it is biased here. Let's see what we have here. It says involves only the people that want to participate. So we know that that's why it's voluntary. The method will not produce an accurate and valid prediction of the total number of dogs in the city. So we cannot get an accurate estimate of how many dogs are in the city here. It's because it's voluntary. Let's look down here and move this down here so we can see it. It says, Mr. Stevens surveyed every 10th student in the hallway to see where they would prefer to go on vacation. So right there, it's systematic because we're dealing with every 10th person here. It says 48% preferred the beach, 36 preferred in an amusement park, and 16 preferred the mountains. Is the sample method valid? Well, we can see that it is. If so, how many of the 560 students in the school can you expect to say they preferred the beach? So if we take a look here, we did say, yes, it is valid because it was a systematic random sample. He was choosing every 10th person. So if we want to figure out about how many students do we think would prefer the beach, we take those total number of students that we have here, which is the 560. And then we're going to multiply that by the 48%. So when we do that, 560 times 0.48 equals 268.8. We're going to round that. We're going to say, hey, that's going to be approximately 269 students will prefer the beach. Real world example, last one here. It says, from a batch of 7,500 computer chips produced, the manufacturer sampled every 150th chip at random for defects and found that 2 were defective. Okay. Is a sampling method valid? Well, yes, it is, because we're doing on every 150th one. Okay. So it is a valid method. If so, find how many of the 7,500 computer chips can you expect to be defective? Okay. So if we take our total chips that are produced, the 7,000, circle this here, the 7,500 computer chips. And we know we're going to survey every 150th one. So if we do this, so we do 7,500 divided by every 150th one. So that says, hey, we are going to be checking 50 chips. Okay. Now we know 2 are defective out of those 50 chips. So 2 out of 50, so 2 defective chips out of a total of 50 chips that we surveyed here will give us 0.04 or 4%. We expect that will be defective. So now, if we know if it's 4% that are defective, we take that 7,500, once again, that's our total amount here, and we multiply it by our 4% or 0.04. So we expect out of this 7,500 chips, we expect 300 of those chips to be defective. So hopefully you understand what we talked about today. Get ready to start your homework and have a great day.